So, in the previous sessions, we have seen interference produced due to division of wavefront, and in this session we will see interference due to division of amplitude. So, here we will discuss color of thin films and Newton's rings. So, color of thin films. We have observed that when we drop some oil drops, some petrol oil drops on water surface, the surface appear to be colored. The compact disc, we have noticed the brilliant display of rainbow colors from a compact disc, and we are going to see how these are forms. So, first we will see color of thin films. So, color of thin films, suppose this is a thin film, some oil, we can assume some oil on water, and this film should be thin, means the thickness of the film should be in comparison to the wavelength of the light. So, if it is thick, then for thick distances we can't get interference pattern, for thin films only we can get. So, what is generally done? The interference is studied. Suppose this is a ray, then it gets reflected from this upper end and some portion is get transmitted. Here again it gets reflected, transmitted, and here is again reflected. Again here there is some transmission and some reflection, and again some. So, the series of reflections and transmissions will be there. So, when we keep a screen here, then we will get an interference pattern in this region, that is interference due to transmitted light, that is interference due to transmitted light. And here if I will keep a screen, I will get an interference pattern, that is interference due to reflected rays. Now, this ray may be incident obliquely or normally. Generally, we prefer normal incidence. This may be a point source or this may be an extended source, that is it may be a plane wavefront. So, now one more thing, here the energy at each stage is divided, the amplitude is divided, that is why we call division of amplitude. And suppose here amplitude is something, then only some reflection coefficient is there 25%. So, 100 units of energy, here only 25 units, then here 75 units, again only 25% of 75% will go this way. So, the amplitude of all these waves drastically decreases. So, generally the amplitude of these two is taken, this third amplitude and fourth, fifth, these amplitudes decays and they does not contribute too much in here interference pattern, because their amplitudes are small compared to this. So, generally we take two reflections and here also two transmissions. So, multiple transitions not required, because the amplitudes of these are very small compared to first two reflections or first two transmissions. So, let us see first that how the reflected rays are going to interfere.